introducing darts, which is a time series analysis library written in Python. But you do not need to worry, it's not now a 10-minute sales pitch for Unit 8, because darts is completely an open source library. So everybody can access it. If you want, you can look up the code and just use it for yourself with basically no strings attached. So over the next 10 minutes, I will just give you a quick introduction into time series forecasting, or why you should care about time series, then why we developed darts at all and why we made it open source. And then I'm going to give you a quick demo, because I think that's the best way to show a new library, is just show how it works and how easy it might be for the end user, because this was really our goal, to make it easy for an end user to analyze all the time series. So the good thing about time series is that they are really easy to motivate, I would say, because they are simply everywhere. In every industry, every business, you have some form of time series. For example, we at Unit 8, we had a lot of, for example, financial or sales forecasting, or myself, I worked on cash flow forecasting. But at my previous employment, I worked more on biostatistics, and I did, for example, I worked in healthcare and did hospitalization forecasting. So it's really a statistical method which is everywhere and just in every industry there is. So we from Unit 8 really thought, while working on some client projects, thought it should be really easy for everyone to analyze them, because we think that many businesses just miss out on correctly analyzing them. Because while we worked on several client projects, we noticed that there are just a lot of different libraries that you need to use, especially in Python, for example, to get your full time series project going. So that from full data discovery, pre-processing, some forecasting models, especially if you want to forecast, for example, some classical models, you need at least 2 to 3 libraries. If you then want to use some more modern machine learning, AI, deep learning methods, you really need to learn a completely new framework, for example, TensorFlow or PyTorch, just naming 2 examples. And we thought it should be much easier, that you should not have to import or learn and read the documentation of about 10 different libraries, but just hopefully one. And this is what we actually tried to do with darts, inspired by real-world use cases with some of our projects. So it first started as, I think about 3 years ago, more as a tool for ourselves. We didn't really plan on releasing anything, because we just noticed that we had the same problems over and over again. We just wanted to make it easier for ourselves. But then after a few years, we noticed that really there was a whole library in there, and we thought we could also give a little bit back to the open source community, and just published it around 1 year ago, I think in June of last year, just to see what people thought about it, and maybe if people could even improve on it. And we were really happy to see and excited to see that a lot of people thought it was useful. So in this 1 year, we got a lot of traction, a lot of recognition and attention, which was really nice for us. And we also got a lot of feedback from people, what we could improve and how they used the library and what they liked about it. So it has really been an interesting year. So what time series darts really tries to cover the full time series product life cycle, from discovery, so from data visualization, fitting naive models just to see what's possible, to pre-processing with interpolation of missing values and train test splits, all of that stuff. And also the main current, or the probably the most juicy part, is the forecasting models, where we currently, I think, offer around 13, 14, 15 different models, from classical models, which prove to really work over time, like ARIMA and exponential smoothing. But we also try to stay on top and also implement some of the cutting edge technologies like NBeats or some deep learning methods. And of course, if you have that many models, you need also a method for model evaluation, model selection. So that's also included. And I think this was everything I wanted to show so far. The rest will be basically just a quick demo. And I hope everything works. I tested it a few times. Otherwise, I have some fallbacks that I can revert to, but I hope that everything works. Normally, everything goes well on demos, on live demos. So the first, even if you're not really a Python programmer, you do not really need to worry. I will highlight the important parts of the library, or what we try to solve, because even if you don't use Python, you will see how easy it is to use. The first 2 blocks here that I run are just for importing darts and importing mainly the different models that you will see later, and for reproducibility. So if you want to run this notebook at any point that we will upload it, you will get exactly the same results. So like mentioned in the previous talk, you first need some data. We expect that you already got some data in one form or another, for example, as a CSV. Then you need only to load it and transform it to a time series object, which is the main object here in Darts. As soon as you got the object, you're pretty much good to go, and you can use everything that is included in Darts, even without using a lot of Python itself. And we try to make it as easy and as flexible for you to get this time series object. So this is what I do first. We are going to analyze the energy dataset, which is a real-world dataset from a Kaggle challenge, where we try to predict the hourly price of energy, because this was really identified as one of the core contributors to really help with climate change and also help different businesses as well. So we're doing just a little bit of pre-processing, but I will focus more on the model part. But first, it makes it very easy with one line of code to plot the data set over the whole range. You just have to specify the column, but then you can just plot it over the 4-year period and hourly data, hourly measurement point. For pre-processing here, I just will drop all the data before the December of 2018. So I will just keep the last data here. I would not do this in reality. I just do it here to make the model training a little bit fast and that you can really see something, because this year is quite messy, but I wouldn't recommend this in reality. And then you see here on the next plot that we really get just the last month of the data, and we already did a train test split. So we will train the models on this data set here and test it on the blue one here to know how the model performs on unseen data. Then we try to fit or define a lot of different models in just one block here. So all the ones we imported previously. I will start it now because it takes a while on my current laptop. Normally it's a lot faster. I hope it doesn't get too much slowed down by presenting, but it should work here. We can already see that the first 3 models have already been fitted. And you can see here that the model definition is quite easy. All of them have sensible default parameters, or at least that's what we try to do. So the only thing that you need to decide is how many previous points you want to use to predict the next time point. For hourly measured data, it's really intuitive to choose a lag. It's called a lag of 24. So you use the previous 24 values to predict the next one, because you expect a seasonality or a period of 24 hours. And then the really nice thing about Darts is that you can simply use all these models, all these different ones in just 2 lines of code basically, and all work in exactly the same way with called fit and a predict method. This basically is all that we try to do with Darts, make it as easy as possible for the end user. All of this here is just for plotting. So now this should already be done by now. It's just probably because of the presentation that it doesn't really fit. We are now at the last stage, but I switch over probably to the already prepared one, just that we don't have to wait forever here. But it's exactly the same code. So again, we were here, and we just use this fit and predict method and then plot the results. Currently, I don't want to show if the models are really that good or if they work or not, but just how easy it is to use them and how easily you can get really sensible results. So for example, all of those here, for example, ARIMA or exponential smoothing, lead to really reasonable results by not changing any of the default parameters. And this is the case for most of those data sets that we analyzed so far. And the good thing, or the thing that we really try to do, is that deep learning models work exactly the same way. Again, I won't run the code here because this is already a prepared one, but this shouldn't take too long, about 30 seconds, if you don't have a potato like me currently here. But here, the deep learning method, like one of them is called NBeats. It's really been popular over the last few years. And it works exactly the same way like all the classical models before. You just define the models. Here I have to define just some more hyperparameters, just that it runs in a reasonable amount of time. If you use the default parameters, it also looked nice, but it just took about 1 minute 30 to really produce some results. So I just chose a smaller one or a simpler one. Then again, just like before, you can simply call fit and predict and get reasonable results right away. And this is the whole point of Darts. Choose a model, see how it works really quickly, and then you can fine-tune it. But you can get results really extremely quickly. As my time runs out, I will not really go over all of the rest here. if you know what ensembling is, it's just that you combine several models into one big model to hope to improve the results. It's also done in Darts extremely easily. You can just define your ensemble model and then call exactly the same fit and predict. And the rest we will upload this Jupyter notebook. You can look over the rest yourself. A lot of it is now model selection and using external variables. But I will leave it for now and hope that you already got a good insight on how the library works and how easy it is to use. So let's go back to the main presentation, just a few main key points here. Library Dart should be an all-in-one solution, so you can really do everything from pre-processing up to model selection, all in one place. And if you read some documentation, you just need to do it for one library, not for 10 or a dozen or more. Also, it leads to increased speed, not really for model fitting. Model fitting is just the same like with other libraries, but just that you don't need to spend so much time defining your models, reading the documentations, setting up the code, setting up different code for different libraries, and then analyzing the results separately. You can all do it in one place. And lastly, it's also open source. So if you have any problem with it, either you look at the code yourself or you can contact us anytime on GitHub or via our email. It's just, if you have any problems or improvements, just let us know, and we're always happy to discuss. So as next steps, I would suggest you just to try the library yourself on one of your datasets that you probably have, or use one of ours that we already pre-implemented. And if you want, you can also watch some introduction videos or just look at notebooks, which is probably the best idea. Just run the code yourself. Otherwise, for problems or questions, you can always ask either Unit 8, so at this email down here, or myself. So we're always happy about feedback, how you use the library, if you use it, and what kinds of improvements we can make that you can solve your problems more efficiently.